how could we have evolved? Because the eye is so complex. For example, we've got cameras in the studio here, and they need camera operators to pull focus and to be able to change shots and everything. And the more distance or close-up you get, you have to change the actual iris of the camera, perhaps even open it or close it a little bit. So that's all done instantaneously within the brain, the human brain. And it's so complex that I thought, how could we have been bumping around without sight for thousands or millions of years if we've evolved, when really it needed to be functioning from the word go?
Well, yes, all right, I will answer that question. Certainly, you're absolutely right. The eye is a most remarkable organ, and it does the same sorts of things that these television cameras do. It does instant focusing. It does instant stopping down with the iris diaphragm. It's got full colour, three colour vision, just like modern televisions have, and it is a remarkably beautiful. It's not totally flawless. There are interesting flaws, interesting imperfections, which actually are revealing. Nevertheless, it does work very well, and an engineer would give it somewhat high marks for being well, quote, designed. Now, you raise the question, doesn't it all have to be working before it'll work, it's any good? How could we bump along for millions of years with only half an eye? That's a bit of a fallacy, because actually only a quarter of an eye, only a hundredth of an eye is better than nothing. You can make a slowly climbing ramp of improvement from just the very rudiments of vision, just say being able to tell the difference between light and shade, nothing more than that, right up to the perfection of a human eye or the eye of a hawk, say. And in order for evolution to explain that, all we need is that there should be a ramp of improvement where every step, a hundredth of an eye, 200ths of an eye, 300ths of an eye, etc., 50% of an eye, 51% of an eye, each step has got to be an improvement on the one that went before. And it's easy to see why that would be. You start by being able to tell whether there's a shadow, whether it's night or day. Shadow's useful. That could be a predator moving overhead in the sea. Night or day is obviously useful for all sorts of purposes. Then you could imagine a cup. Instead of just having a flat sheet of light-sensitive cells, the edges turn up into a cup. Now, the cup means that if there's light coming from that direction, it hits that part of the eye. If there's light coming from that direction, it hits that part of the eye. So already the animal can tell the direction from which light is coming and the direction from which a shadow is coming. So we haven't got an image yet. All we've got is the direction of light. Now the cup can steadily and slowly over evolutionary time close over until you end up with a little hole at the top. And the little hole at the top, the same principles working all the way, that light coming from that direction hits that part of the retina, and from that direction hits this part of the retina. But because there's a hole, it's rather more precisely, not exactly focused, but light from there hits there, light from there hits there, light from there hits there, because it's got to get through the hole. We're moving towards a pinhole camera. Now, a pinhole camera, if you make the hole small enough, and remember we're having a smooth gradient of closing up the hole, if you make the hole small enough, then it makes a sharp, focused image. The trouble with a pinhole camera is that the image is very dim because very little light can get through the pinhole. What you need is a lens, because what a lens does is gather light from different directions and focus it on a point. Instead of it having to go right through the middle of the hole, it can be gathered from a wider range of sources. Now, a lens is not difficult to arrange. Any old chunk of transparent gubbins will do the job better than a pinhole. So once again, we've got a slow, gradual improvement. Any old lump of gubbins, transparent, is better than nothing, and then the lens simply improves its shape gradually, gradually. It's got to be gradually. Every step has got to be a slight improvement over the previous one. You get a lens.
Can I just ask you though, Richard?
Yes.
How long did this process take?
Well, that's very interesting. I mean, we've got hundreds of millions of years to play with, because that's what geological time gives us. I mean, we've got maybe a billion years since the first eye, since the first focusing eye appeared.
As a creationist or believer in creation, the book of Genesis, you know, I would disagree with that. But
what would you disagree with?
With the time. The timing
how old do you think the world is then?
I would say that because I'm a Bible-believing
yes.
Christian, that I believe that the book of Genesis is in actual fact the record, because Christ as well referred often to the book of Genesis, that in the beginning,
yes, yes.
Adam and Eve, and I know that. But before we get onto that, say, just as a layman, I had to come to terms with, you know, how on earth did we function? And the heart, for example, the lungs, the liver, the kidneys, and particularly, don't want to be too personal, but how do I take a leak if I have to wake up a few million years to do that?
Wait a minute, I don't understand.
Well, if I was to go to the toilet, you know,
yes.
I mean, how did we evolve with the ability to release waste? If we were waiting for certain organs to develop?
Well, no, it's not really like that.
I know it's a simple question, but I'm a simple man.
I mean, you don't wait millions of years. It all happens. There's a continual improvement going on all the time, continual changing. I mean, the way things work is different now from the way it used to be. I mean, I tried to give you a rather detailed exposition of the eye, and you switched to something else. I mean, did you find that convincing, what I said about the eye?
Well, not really.
Well,
but I understand. And I don't mean it condescending,
because I gave you the gradual ramp of improvement. What I didn't quite have time to say is that if you look around the animal kingdom today, and you mentioned trilobites, but there are lots and lots of animals which show eyes in all sorts of what we might think of as states of sort of half-development. I mean, there are flatworms that have just a cup for an eye, no lens, not even a pinhole. There are animals like Nautilus, which is a sort of coiled-up squid kind of thing in a shell, which has a pinhole camera for an eye. So each step of the way that I told you about might have been hypothetical, but you can find an animal somewhere around the animal kingdom, a living animal, which actually does it. So I don't understand why you don't find that convincing.
Well, let me tell you what happened in my brain at that particular moment in time was that I was thinking of the book of Genesis, and where God says that he made everything according to its kind, and that it was, and we stayed within those groups, and we didn't evolve. So I find it difficult, and because I suppose my present position dictates to a certain extent, what I believe, and I've got to ask questions in such a way as to help me to see the other side, that's all. And
yes.
I'm putting it quite simply.
Let me get this right, because what you're saying is that the book of Genesis, it takes precedence over science. You're saying that a book that was written, when, about 800 BC, written by whom? By some scribe during the Babylonian captivity. Why would you believe?
It goes back further than that, and certainly most Bible scholars have attributed the book of Genesis to Moses.
Oh, really?
Yes,
to Moses?
Yes. But
Bible scholars attribute it to Moses. I know
so.
You attribute it to Moses,
yes.
but
yes.
Can you name a Bible scholar who attributes it to Moses?
I can't at this moment in time,
okay.
just off the top of my head, but
okay.
that doesn't stop me believing in God.